I want to find the limit as h approaches 0 from the right of the square root of h squared plus 4h plus 5 minus the square root of 5 over h. The first thing I should do is plug in 0 for h. And when I do that, I get 0 over 0. So the way I'm going to solve this limit is by taking the conjugate of the top and multiplying it to the top and the bottom. So the conjugate will just be the square root of h squared plus 4h plus 5, and then plus square root of 5 over the square root of h squared plus 4h plus 5 plus square root 5. So when I do that, at the top I have a situation where it's a minus b times a plus b, and by a difference of two squares, this should be a squared minus b squared. So here a is going to be the square root h squared plus 4h plus 5, and b is going to be the square root 5. So this simplifies to h squared plus 4h plus 5 minus 5 all over h times the square root of h squared plus 4h plus 5 plus square root 5. Now the 5's are going to cancel at the top, and now I can factor out an h from the top. So I have h plus 4 so there's a factor of h at the top, a factor of h on the bottom, so those are going to cancel. And now if I plug in h equals 0, at the top I get 4, at the bottom I get root 5 plus root 5, so that would just be 4 over 2 root 5. Simplifying, 4 divided by 2 is 2, so it's 2 over root 5. And now we can multiply the top and the bottom, if we want, by root 5 to get 2 root 5 over 5. Okay, so that's our limit. Let's look at another one like this. So let's say we have limit as h approaches 0 from the left now of the square root of 6 minus square root of 5h squared plus 11h plus 6 all over h. So the first step is plug in 0 for h, and you end up getting 0 over 0, just like the last problem. So we're going to multiply by the conjugate of the top. So it's going to be root 6 plus square root 5h squared plus 11h plus 6. And we're going to do the same thing at the bottom. At the top we have a situation where it's a difference of two squares. So in this case, root 6 will be a, and root 5h squared plus 11h plus 6 is b. So we end up getting 6 minus the quantity 5h squared plus 11h plus 6. And here we have to be very careful to put the parentheses around there, because b does not involve the negative. B is only the square root part. So you're squaring only the square root part, with the minus being outside of that. Okay, over h times square root 6 plus square root 5h squared plus 11h plus 6. Now at the top, the 6's are going to cancel, and we're going to be left with negative 5h squared minus 11h. So here I just distributed the negative all over h times the quantity square root 6 plus square root 5h squared plus 11h plus 6. At the top now I can factor out an h. So I'm left with h times negative 5h minus 11. And at the bottom I still have the h factored out. So I can cancel out the h now. And I can plug in h is 0. So at the top I get negative 11. At the bottom I have root 6 plus root 6. So that would just be 2 root 6 at the bottom. And we can multiply by root 6 top and bottom to rationalize the denominator. And our final answer will be negative 11 root 6 over 12. Okay. Next we're going to be looking at absolute values. So let's say we have limit as x approaches negative 2 from the right of x plus 3. X plus 3 times the absolute value of x plus 2 over x plus 2. So because we're approaching it from the right, well, let's see first. Let's look at the graph. So this is the absolute value of x shifted over left 2 units. Okay, so that's the graph. And notice at the left, this graph is just the negative part of x plus 2. And this part is just the positive part of x plus 2. So if we're approaching it from the right, we're obviously coming down from this line right here. So the absolute value of x plus 2 is just going to be x plus 2. So we can write it by definition. It's going to be negative x plus 2 if x is less than negative 2. And it's just x plus 2 if x is greater than or equal to negative 2. So because I'm looking from the right, I want x plus 2. So we can rewrite the limit so we'll have x plus 3, and it'll be x plus 2 over x plus 2. Okay, so that would just cancel. And all we have is x plus 3. So the limit as x approaches negative 2 from the right, we'll just plug in negative 2 to get 1. So 1 is the limit there. Now let's compare this to what if we looked at the limit as x approaches negative 2 from the left. Okay, so we still have the absolute value here. So this is the original function. Now from the left of 2, negative 2, we're over here. Clearly, that's this function, negative x plus 2. So negative times the quantity x plus 2, which is the same thing over here. So we can rewrite this as limit as x approaches negative 2 from the left, x plus 3. Now x plus 2 will be negative times x plus 2. So we could say negative x plus 2 over x plus 2. And the x plus 2's are going to cancel. So we'll have a negative here. So this negative, think of it as like it could go in front here or in front there, which is really the same thing as what we had over here, but the exception is there's a negative. So instead of 1 being the limit, we'll just have negative 1. Okay. So our limit is -1.